Hello guys, welcome to Volta Solutions and welcome to your grade 10 trigonometry. Today we are looking at the cast diagram. Most of us who are doing trigonometry are familiar with this cast diagram. Before we get to use it, let's try to understand where this cast diagram is coming from. Okay, so you guys will recall that, let me highlight this, that we are dealing with the cast diagram. Okay, let me highlight that we are dealing with the cast diagram here. You guys recall we used to withdraw functions, let me say in the domain 0 degrees to 360 degrees. All right, 0 degrees to 360 degrees. So you guys are familiar with all the graphs. Let's say this is y and this is x. Your sine graph would have this shape here. In other words, it would look something like this. Let me say this is sine x. And then your cosine graph would be like this, right? This is your cos x. And then you have your tan x. It has asymptote at 90 degrees and at 270. It looks something like this. Maybe I should have used the red color. The blue and the white. Okay, no, it's okay. It looks something like this. Okay, it looks something like this. Right? So this is your tan x. I'm sorry I didn't draw it to scale, but I hope you guys have an idea. Right? So I'm now going to introduce some lines. Don't know what color I should be using. Let me say this. For between 0 to 90, it's what you term your first quadrant. And then 90 to 180. Okay, let me do this. No, it's going to be messy. 90. Yeah, let me try them here. This is the first quadrant. This is the second quadrant. This is the third quadrant. And this is the fourth quadrant. Can you see that? Between 0 to 90, it's your first quadrant. 90 to 180, it's your second. 180 to 270 is your third quadrant. 270 to 360 is your fourth quadrant. Now, let me now remind you of your cast diagram. So you have a cast diagram. Let's say this is 0, 90 degrees, 180 degrees, 270 degrees, and what is this? 360 degrees revolution. So going back to these graphs here, or this chart, can you see that in the first quadrant, all ratios are above the x-axis, meaning all are positive. One of the reasons you say this is A, gonna come back, done with that. Now let's go to 90 to 180. Only sine is positive. Can you see that? Only sine is positive. All right, only sine is positive. Let me do this. Only sine is positive. Now let's move from 180 to 270. You get it? One that is above the x-axis is tangent. Can you see that? So this is the third quadrant. So in the third quadrant, it's tangent that's positive. Can you see that? It's tangent that's positive. Okay, moving on. 270 to 360, which is the fourth quadrant, only the cosine is positive. Alright, only the cosine is positive. Now, this is why we are saying cast diagram. In the fourth quadrant, cosine is positive. In the first quadrant, only all ratios are positive. In the second, only sine is positive. In the third, only tangent is positive. And like I said, in the fourth, only cosine is positive. You guys now have an idea where this cast diagram is coming from. Remember, this is the first quadrant, second quadrant, third quadrant, and fourth quadrant. Right? Perfect. So, having said that, there are questions that you are going to come across when you are in this section. Okay? So, we are not going to waste any time, but I should assure you, when you're using the cast diagram, if you are looking for sine whatever, that is a point, maybe the angle was here, sine will be positive and the rest will be negative. Now, we will try examples where you are going to see this. Okay, perfect. Let's get into it. So, let's try our examples. So, in our examples, let's try maybe this point here. Let's try this point here. Okay, I'm gonna draw this. Let's say it's this guy here. And then let's say the point here is point P with coordinates -12 and 5. Okay, and of course this angle here is angle alpha. Okay, this angle here is angle alpha. Okay, this angle here is angle alpha. Remember, this is x and y. What you do not have is r. So basically, you can draw this like this, drag it down. This one here is the x value. What is it? It's -12. And this one here is the y value. What is it? It's 5 units. Can you see that? Can you guys see that? It's the y value. It's 5 units. Okay? It's 5 units. So, what you need to do is to find, let me remind you that this is the origin. What you need to do is to find OP. Okay? The question maybe I should ask this. I should say, 1, find OP first thing first. Find 1, OP, or determine OP. 2, I should say sine alpha. 3, cos alpha. 4, tan alpha. 5, I will say cosec alpha. Okay, 5, I will say cosec alpha. Okay? Right. So, to answer number 1, our solution, to answer number 1, this is basically a right-angled triangle. And we are going to say, okay, if this is the case, we can basically say we have OP squared equals, what is this? Let's call it x squared plus y squared, which is OP squared is equal to, what is x? X is -12. What is y? Y is 5. Of course, 5 squared. So when I look at it here, OP squared is 169. Okay, if you add all these together, or let me not rush it, this is 144 plus 25. Okay, plus 25. Okay? So, OP squared equals 169. Therefore, OP is square root of 169. What is the square root of 169? It is 13. Right? It is 13. So what you have now, you have your hypotenuse, adjacent, and opposite. Okay? So, now, the question says to you, you are looking for sine theta. That's the second question. Sine, oh, was it theta or alpha? Alpha. Yes, it's sine alpha. Okay? It's sine alpha. So, what we do normally with this, we like thinking that, of course it's right, and you will see why it's right. That we see that this is alpha here, but if you were to draw your small triangle here, it's basically your alpha, it's here. Okay? Your alpha is here, and what is this? This is 5. What is this? This is 12. Let me just write 12. And what is this? This is 13. Okay? This diagram here, this smaller triangle here, looks like this one here. Okay? But pay attention to the signs that you are using here. Okay? Pay attention to the signs that you are using here. So I right now do not want to dwell much onto why I'm saying this angle is here. You will get to see this more in grade 11. However, you are okay to say this is 180 minus alpha. Okay, you are okay to say this is 180 minus alpha, which you will understand more in grade 11. Okay, so for now, assume that it's like this, but pay special attention here. This is a negative 12, okay? But because it's a distance cannot necessarily be negative. But for now, just assume it looks like this. But I will be taking into consideration the negative. Okay, or maybe let me place it. Okay, so we're looking for sine alpha. What we know, SOHCAHTOA, sine is opposite over hypotenuse. So what is the opposite? Here is it? It's 5. Okay, so it's 5 over, what is the hypotenuse? Here is the hypotenuse, OP. Alright, what is it? It is 13. So this is your sine alpha. Moving on. Number 3, we are looking for cos alpha. Number 3, we are looking for cos alpha. Cos alpha, again, cosine is adjacent over hypotenuse. What is the adjacent? Yes, it's 12 units, but this is negative 12 because it's in the second quadrant. So it's negative 12. What is the hypotenuse? We said 13. I'm going to explain why we got this shortly after doing number 4. Now, tan alpha, tangent is opposite over adjacent. What is the opposite? It's 5. What is the adjacent? Negative 12. Alright, so it's 5 over negative 12, which we can say it's negative 5 over 12. It's okay like this. Alright, now, something that I wanted to explain is this. When you look at this point here, this angle is in the second quadrant. Alright, this angle alpha is in the second quadrant. In the second quadrant, sine is positive. Yep, sine is positive. Again, in the second quadrant, cosine is negative. Tangent is also negative. Right? Tangent is also negative. Now, let's look at it. Go to the cast diagram. In the second quadrant, only sign is positive. Now you get to see why I had to emphasize this point here. Right? Happy? Perfect. Now we can check cosec alpha. Now, cosec alpha, you still remember cosec is a reciprocal of, what is it a reciprocal of? It is a reciprocal of sine. If it's the reciprocal of sine, what will it be? It will be hypotenuse over opposite, right? So this is 13 over 5. Remember, if you are confused here, you can always refer to that video on reciprocal ratios, right? Or reciprocal of ratios. Okay. So cosec alpha is 13 over 5. Okay. Perfect. Now, we are done with this. This is what it means. Sometimes you will not be given information like this. You will be given a word statement and you must convert it to your thingy, your diagram. So let's say given cos theta equals 8 over 17, where theta, maybe let me write theta like this, where theta, or I should say and theta is greater or equal to 180 degrees, but less or equal to 360 degrees. Right? I will say, find, let me say find 1 sine theta, or before that, yeah, find sine theta, it's fine. Number 2, tan theta. Okay, number 2, tan theta. So, a thing that you must ask yourself is that you are given that cos theta is 8 over 17. This is a positive cos theta. In your cast diagram, your solutions, in your cast diagram, first, second, third, fourth, cosine is only positive in the first and the fourth quadrant. However, the angle given here, this angle here, must be here. This was angle theta, right? This was angle theta. The point was, I do not know, but all I know is that you are given hypotenuse. What was the hypotenuse? Hypotenuse was 17, and because it's cosine, adjacent over hypotenuse. What is the adjacent? It's 8. So basically, it's 8, and I do not know what the y value is. Can you see that? So this is me now trying to represent this into a diagram. Okay? Given it in this way, here is the point I'm looking at. Because cosine is adjacent over hypotenuse. So this is basically our theta here, our smaller theta, right? So now we can find the y. And my expectations are that this is in the fourth quadrant. As you can see, x values are positive, but y values must be negative. Therefore, let's do this. We can say, if you like, we can say 17, or maybe let me do this, r squared equals x squared plus y squared. I know there are those that prefer it in this way. I like calling it OP, but you can call it r squared, it's okay. What is it? This is the r, or what we call OP. It's 17. What is the x? It's positive 8. I do not know what the y is. So 17 squared, what is it? 17 squared is 289. 8 squared is 64 plus y squared. So 289 minus 64 is equal to y squared, which is 225 equals y squared. We are not done. Square root of 225 equals y. Remember, it should be plus minus square root of 225 is equal to y. Okay? So this is plus minus 15. Square root of 225 is 15. However, this point is in the negative y-axis. Therefore, our conclusion are, therefore, y is equal to negative 15. Okay? It's negative 15. Now, answering the question, number 1, we're looking for sine theta. What is sine theta? By the way, we expect sine theta to be negative because the point is in the 4th quadrant. So let's see. Sine is opposite over hypotenuse. What is the value of the opposite? This is the y. Remember, it's the y. What is the y value? We got negative 15 over hypotenuse. What was the hypotenuse? It was 17 over 17. Okay. Now, number 2, cos, it's tangent. Tan theta is opposite over adjacent. Tan theta is opposite over adjacent. The opposite side is this one here, which is the y, which was minus 15. What was the adjacent? The adjacent was 8. Right? The adjacent was 8. Now, as you can see here, sine theta and tan theta are negative. Yes, we are in the 4th quadrant. Only cos theta was positive. The rest are negative. As you can see, cos theta is 8 over 17, positive 8 over 17. Sine theta is negative 15 over 17, while tan theta is negative 15 over 8. It makes sense. When you refer to the cast diagram, indeed, it should be like that. Can you guys see that? It should be like that. So in the 4th quadrant, only cosine is positive. So this is how you will be doing questions on the cast diagram. Okay. So remember, guys, please subscribe. Do not forget to like, and you can also share with your friends, and we would appreciate your subscription. So with that being said, it's a wrap. See you next time, and bye bye.